Okay, so let's do an example here of a patient who is 27-year-old male who was in a house fire, has a burn extent of 18% and weighs 220 pounds. So what's important here is we have to first figure out the weight. So this is in pounds and everything that we're doing is in kilograms, so I got to convert this. So first, I'm going to do my conversion of 220 pounds divided by 2. That's going to give me 110. I'm going to minus by 10%. 10% is roughly 10. So that is going to be an answer of 100. So my 220-pound patient is 100 kilograms. And remember, the magic number is 2.2 pounds per kilogram. So we have our first rule of tens. I have my body surface area times 10. So 18 times 10, a total rate of 180 milliliters per hour. But I have my patient is 100 kilograms, and we said anything over 80 kilograms, I'm going to add 100 milliliters per hour for every 10 kilograms. I have 20 kilograms, so I'm adding 200 milliliters per hour. So I will plus 200 milliliters per hour equals my total rate of 380 ml per hour, right? So that's going to be using the rule of tens, 300 mLs per hour. What I'm going to do for my consensus form is 4 times my patient's weight, which is 100 kilograms, and then multiply that by the body surface area, which is going to be 18%, and that's going to give me a total of 7,200. That's a 7,200 mLs in 24 hours, right? In 24 hours. 24 hours. Okay, so in this case, the what I have to do now though is I need to split this up because again, we're doing the first half of this 7,200 mLs. We're doing that in the first 8 hours. So I kind of do this, split 7,200 in half, and that's 3,600 and 3,600, right? So 3,600 mLs in 8 hours. So then how much per hour 3,600 divided by 8 is going to give me a flow rate of 450 mLs per hour. So it's roughly close to the 380 mLs per hour. A little bit of a divergence here, but they're in the same ballpark. So using one of these two formulas kind of gives me an idea of how much fluid I'm giving to the burn patient. Let's do one more. We have a patient that's 38-year-old female who is in a car fire, burn extent of 33% now, and weighs 100 pounds. So similar to before, I have to first convert this 100 pounds to kilograms. So I do my 100, and then I divide that by 2, and that's going to give me an answer of 50. And then I take 10% off of that, minus the sort of tens place here, so minus 5, and that's going to give me 45, oh, 40, sorry, 45 kilograms, 45 kilograms. Okay, so with my 45 kilograms, what I now need to kind of figure out is going to be my tens, my rule of tens formula. And so with this, I'm going to start with my burn surface area, which is 33%, and times that by 10. And that's going to give me 330 ml per hour. So that makes sense. I don't have to really do anything more because they weigh the 45 kilograms, and that's between my 40 and 80 kilograms. So I can stay with the 330 kilograms there. So the next thing I have to do is try to figure out my consensus formula. So I will now kind of put in my numbers. So I do 4, I do 4, and I times this by my patient's weight, which is going to be the 100 kilogram, or I'm sorry, 45 kilograms. And then I multiply that by the body surface area. So that's 33. So I am going to multiply all this together and I'm going to get a total of 5,940. I am sorry, guys. This is harder to write for some reason at the end here. So we have that. Now I will split this into kind of two as I did before, and I wind up with 2,970 and 2,970. 2,970. So again, I'm doing this first 8 hours, 2,970. So I divide this by 8, and that's going to give me a total of 370 milliliters per hour. And that's pretty close to my 330 milliliters per hour. So makes sense.